Okay, we are ready to start and live on YouTube.
Thank you, ma'am. So we live. All right,
Yes,
good day.
we are.
Okay. Good day, grade 12. Today we're still going to carry on with the applications on equation of tangent lines. Yesterday we stopped by the last question of determining the equation of the tangent to the circle, both to the line that was y plus 2x equal to 4. But before we look at the solution, I just want to ask, is there anyone who has a question from the question that we did from 1 to 6 yesterday? If you do have, can you please write down your question so that we can attempt that question before we carry on? Is there anyone who has a question from the first one to the number 6 that we just have in front now? Okay, so we're going to carry on. So the last question, number 7, was for us to determine the equation of the tangent to the circle, both parallel to the line y plus 2x equal to 4. Remember, we found two equations, two tangent equations. Those two tangent equations, we had y equal to negative 2x minus 10, and we had y equal to negative half of x plus 5. So let's just go to the next slide. So we had two equations, y equal to negative 2x minus 10, and we had y equal to negative half of x plus 5. And then in question 7, among those two questions, they say that we have to, among those two equations, we have to find out the tangent, we have to find out equations of the tangent to the circle that are both parallel to the line y plus 2x equal to 4. So you're going to see that the line y plus 2x equal to 4 can be rewritten as y equal to negative 2x plus 4. So you can rewrite y plus 2x equal to 4 as y equal to negative 2x plus 4. And also the first tangent line to the circle that we got, we had y equal to negative 2x minus 10. And the second one, we had y equal to negative half of x plus 5. Now you have to ask yourself, what is, remember we said that two lines are perpendicular if and only if the product of their gradient is equal to negative 1. So this is when you have two lines that are perpendicular. Now, you also have to ask yourself, when do you have two lines which are parallel? So you're going to see that two lines will be parallel if and only if they have the same gradient. So it means that the gradient of, let's say if the first line, the gradient is M1, and the second line, the gradient is M2, the two lines will be parallel if and only if they have the same gradient. So you're going to see that already the line that will be parallel to the equation y equal to minus 2x plus 4 is going to be already y equal to minus 2x minus 10. Among the two, remember we had two equations yesterday, y that was equal to negative 2x minus 10, and we also had y that was equal to negative half of x plus 5. Therefore, you're going to see that the line y equal to minus 2x minus 10, will be already parallel to y equal to minus 2x plus 4. Why? Because they have the same gradient. They have the same gradient, and the gradient here is going to be negative 2. So that's why you can see, so that's why you see that here we have the gradient here, which is negative 2, and also here we have the gradient that is negative 2. Hence, we say that these two lines will be parallel. Now we have to find the second line that will be parallel to the equation y equal to minus 2x plus 4. So what you have to do here, remember we say that two lines here will be parallel if they will have the same gradient. Therefore, you're going to see that the gradient now, to find the equation of the second parallel tangent to the line y equal to minus 2x plus 4, what you have to do here, you're going to see that m will be equal to negative 2. But now you're going to see that the radius now, the gradient of the radius, you're going to see that the gradient of the radius here, you're going to use half. Now, when we go to the next, you're going to see that the equation of the radius here will be y, that will be equal to half of x. Now you substitute this equation into x squared plus y squared equal to 20. Remember, the equation of the circle here was x squared plus y squared, which is equal to 20. So in this case, what you'll do here, you're going to substitute your value of y into this x squared. You're going to substitute it into x squared plus y squared equal to 20. So you substitute half of x into y squared here, and then you're going to get x squared plus half of x all squared, which is equal to 20. The next step will be now just to expand. So you'll have x squared plus x squared over 4 equal to 20. Now when you reduce the like term together, you're going to have x squared plus x squared over 4. When you put this x squared to have the same denominator as x squared over 4, you're going to see that you have 5 over 4 of x squared, which is equal to 20. Okay, so for here, you're going to see that you have x squared, which is equal to 16. And then you'll have two values of x, one that will be 4, and then you have one that will be negative 4. Now, you're going to see that we'll have x, which is equal to 4. If x is equal to 4, when you substitute x equal to 4 to this equation here, you'll find y, which is equal to, you'll see that y equal to 2. Therefore, you're going to have the coordinates 4, 2. Now, when you substitute this coordinate 4, 2 in this equation, y minus y1 equal to m bracket x minus x1, you'll have y minus 2 equal to minus 2 bracket x minus 4. And then when you do solve, you'll have y minus 2 equal to minus 2x plus 8. And then it's going to give you y equal to minus 2x plus 10. So you see that this equation now, y equal to minus 2x plus 10, is indeed parallel to the given equation that we had. You're going to see that this equation is parallel to y equal to minus 2x plus 4. So you can again see that the two lines, y equal to minus 2x plus 4 and y equal to minus 2x plus 10 here, they will have the same gradient, which is indeed here -2. But I'll throw a question at you, and then I'll ask you, in this case, why did I only choose 4? Why did I not use -4? I'm expecting to see some of your answers. So in this case, why are we only using +4 and not -4? Is anyone who can answer this question? Why are we using only +4 and not -4? Anyone? The answer is just in front of you. Remember, just go back to the equation of the circle that is given to you. Remember that the circle here was passing through the center 0, 0. And then you had x squared plus r squared, which is equal to 20. So why are we only using +4 and not -4? Okay, the only reason why we're using +4 instead of using also -4 is because when you look at the equation of the circle, x squared plus y squared equal to 20 here, you're going to see that this is the sum of two positive numbers, isn't it? So you're going to see that x squared plus y squared equal to 20. X squared and y squared, this is the sum of two positive numbers. So there is no way that when you solve even for one of those two variables, you're going to get a negative number, because we know that this is the sum of two positive numbers. So that's why here we only use +4 instead of -4. I hope I've answered. Now, we're going to carry on. Okay, so for today, this is another problem of the tangent line that one can come across. So in here, you're going to see that you have your circle here. You have a circle. You have this tangent line PQ, and then you're going to see that the tangent line and the circle here, they meet at point A. And then you have also the Cartesian plane y, x, and then you also have other points C4, and then you have the point M. Now, I'll ask, what will be the coordinate of A here? What will be the coordinate of A? Can someone answer it? What will be the coordinate of A, this point here? So to get the coordinate of point A, just look at any point in the circle that is aligned with point A. So you're going to see that the coordinate of A, okay, Vanika has said 0, 4. So you're going to see that indeed the coordinate of A here will be x, which is 0, because you can see x is 0, and then you have A, which is having y coordinate as 4. Therefore, you're going to see that the coordinate of A here is 0 and 4. Okay, do correct. The answer is 0, 4. All right, so now we're going to go to the questions. Okay, so you already have the circle with center M passing through A, B, and C, which are having coordinate 4, 4. Now we have seen that PQ here is a tangent to the circle at A. Now Q lies on the x-axis and A lies on the y-axis. Now AC is parallel to the x-axis. You guys, you can also write the question. Now you have the angle, you have ACM, whereby the angle is at C is equal to X, You have BCM, again, where the angle is at C is 2x, and then you have BAM, where the angle is at A is 30 degrees, and then you have CAQ, where the angle is at A is theta. Okay. So the first question was for us to determine the coordinates of A. So you can also write these questions, determine the coordinates of A. That's the first one, determine the coordinate of A. And then the second one is to determine, to prove that X is 20 degrees. B, prove that X is 20 degrees. And then C, prove that A, prove that theta is 20 degrees, 70 degrees. And then B, determine the equation of the tangent PQ. E, determine the equation for radius AM. F, determine the coordinates of M. And G, express the equation of the circle in the center radius form. In the center radius form. Therefore, you have to write the general equation with the center and the radius. So you have already found the coordinates of A, which are 0 and 4. Now, B was for you to prove that X is equal to 20 degrees. So you're going to see that the angle MAC, in fact, the angle MAC here is X, which is opposite equal side. Therefore, you're going to see that opposite equal sides here, you write AM equal to CM. So you write AM equal to CM. And then you'll see that the angle AMC will be a 180 degree because of the interior angle. And then you'll see that the angle ABC, you'll see that the angle ABC whereby at B is 90 degrees. Now, when you add the three angles together, the sum of the interior angle, you have the angle of A plus the angle of B plus the angle of C will be equal to 180 degrees. Remember earlier on, we said that the angle at BC here is, in fact, is 90 degree minus X, my mistake. And then AMC here is 180 degree minus 2X. Therefore, when you add the three, you have 30 degrees plus X plus the 3X plus the 90 minus the X is going to give you 180. And then when you solve for X, you have 3X plus 120. That will give you equal to 180. And then when you solve for X, you have X equal to 20. Is there any question? Okay, now we're going to go back to that circle so that we can see. So if, remember we had, here is the angle, let's say angle AMC. Here is, okay, so you can see that here you have A, M, and then C. So we have A, M, and then we have C here. So AMC here is going to be equal to 180 minus the 2x. And then ABC, here is A. So you have A, B, and C. A, B, C here will be equal to 90 degrees minus the x. And then you have BAM, which is equal to 30 degrees. So edging those three angles, by edging those three angles, so by edging those three angles, that's why you see that you have 30 degrees plus x plus 3x plus 90 minus x equal to 180 degrees. Now, when you solve, you have 3x plus 120 equal to 180 degrees. And then 3x here is going to be equal to 60 degrees, and x will be equal to 20 degrees. So by so doing, you have shown that x here is equal to 20 degrees. Now, the other question was for you to prove that theta is equal to 70 degrees. So you have to show that theta here is equal to 70 degrees. So you know the angle at MAQ here was equal to 90 degrees because it's the tangent of the perpendicular radius. And then we have MAC, which is equal to 20 degrees. Therefore, by so doing, you have shown that theta here is equal to 70 degrees. So MAQ here is equal to 90 degrees because of the tangent that is perpendicular to the radius. And then you have MAC that is equal to 20 degrees. Therefore, you're going to see that theta here is equal to 70 degrees. Is there anyone with a question? So in here, you can have your theta here, which is equal to the theta here, which is equal to the 70 degrees. Because you already know that BAM, we already have BAM, which is equal to 30. And then you know that the tangent here of the perpendicular radius here is equal to, you have the tangent that is perpendicular to the radius. Therefore, you're going to have this theta here. The theta here is equal to 70 degrees. Now, when you were asked to find the gradient of PQ, the only thing that you have to do here is to know that if this theta here is 30 degrees, remember that the angle, let's say PAQ, is going to be equal to 180. Therefore, this angle here, the P, you're going to see that you have P AQ is 180, and then you have CAQ is equal to 30. It means that CAP is going to be equal to 110. Therefore, to get the gradient of PQ, you just do the tan of 110. So you're just going to do the gradient of tan 110 is going to give you the gradient. So you just do the gradient of PQ is going to be equal to tan 110. So MPQ is going to be equal to tan 110. And then once you have this gradient here, once you already have this gradient, remember, we have said that the point Q, we have said that Q here, we had, let's come to the circle again. So we have said also on this circle that we have, sorry. So we have said, remember we said that A here We have said that A here, we had the coordinate 0, 4. We have the coordinate 0, 4 here. Now, knowing the gradient, and we know that the point, it passes through a point 0, 4, and then you know the gradient of the tangent line PQ. Therefore, you can use that point 0, 4 to get the equation of PQ, knowing already the gradient. So by so doing, when you substitute the point 0, 4 into the equation y minus y1 equal to m bracket x minus x1, you're going to see that you have your y that will be equal to you have y minus 4 equal to minus 2,75x plus x, okay, y minus y1 equal to m bracket x minus x1 plus c. But now you see that x minus x0 here is 0. That's why we have minus 2,75. And then y minus y1 here is minus 4. Therefore, when it goes to the right, it becomes positive 4. Hence, you're going to see that our c here will be 4. Therefore, the equation of the tangent line here will be y equal to negative 270,74x plus 4. Okay, I see some question here. Okay, Ndu is asking, where did I get negative 2,75? Okay, so you're going to see that negative 2,75 is the gradient. It comes from tan of 110. It comes from tan of 110. So that's why we say that tan of 110 here is going to give you that gradient. Okay, that's correct. All right. Now, once you have determined the gradient of that tangent line, you just substitute also with the point 0, 4 into the equation y minus y1 equal to m bracket x minus x1 plus c. Okay, I see some questions. Okay, Refilwe is asking the 4 in y equal to minus 270,75x plus 4 from the coordinate of c. I'm lost. No. Remember, you have a point. A is a point that is in both the tangent line and also a point that is on the circle. Oh, earlier on, you found that A was 0, 4. You already know the tangent line, the gradient, you know the gradient of the tangent line M here is minus 2,75. Or you know the equation y minus y1 equal to m bracket x minus x1 plus c. Now you're going to use that point A. You use this point A04 because it's a point on the circle and also it's a point on the tangent line. Therefore, you use this point A for you to be able to find your constant C. So when you substitute, therefore you're going to start the y1 here is 4 and the x1 here is 0. Oh, you already know that the gradient is minus 2,75. Therefore, you say y minus 4 equal to minus 275 of x, because x1 is 0, plus c. Therefore, you're going to see that your c here is going to be equal to 4 when you have y equal to minus 2,75x plus 4. Therefore, you're going to see that the c here is 4. So you get the 4 from the y coordinate, which is 4 here. You get it from A, which is a point on the tangent line. I hope it's okay. So the 4 is coming from A, which is 0, 4. It's not coming from C. A here is a point on the tangent line, and you are looking for that equation of the tangent line PQ. So you use that point A. Is there any question? Is there anyone else who has a question? Prefere is saying thank you now. Is there anyone else with a question? Okay. All right, so we're going to carry on since there is no more question. Now the next one, it was for us to find now the gradient. Let's just go to the questions so that you also read. So the question was to determine the equation for the radius AM. So the question here was for you to determine the equation for the radius AM. Now, when you look at your circle here, looking at the circle here, here is the radius. So you have the radius here. Here is a point A, and then here is a point M. And M here is the radius, and you are looking for the equation of that radius. So what you'll do here, is to find the gradient. Remember, you already know the gradient of PQ, isn't it? You already know the gradient of PQ. And then if you look at AM, looking at AM, you're going to see that AM here is also perpendicular to PQ. The line AM here was perpendicular to the line PQ. Or you know that two lines are perpendicular if the gradient is -1. That's why you see that we write the gradient of AM times the gradient of PQ is equal to -1. So you say gradient of AM times the gradient of PQ is equal to -1. Now, you're going to see that you had, so you're going to see that the gradient of A of PQ here was -2,75. Therefore, when you do -1 divided by -2,75 is going to give you 0,36. So in fact, it's 0,363. So you round it after 2 decimal places, so it's going to give you 0,36. And you already know, you already have that gradient. So the only thing that you are left here is to find C. Okay, Carlos is asking, please you could show us a picture of the circle. Okay. So you're going to see that AM and PQ here. Sorry. Okay, so we're going to see, here is the circle. So where is AM? If you look, here is PQ. Let's just look. If you check, here is PQ. So here is your PQ. If you check here, you have PQ. And then if you check here, you have AM. So you can see that AM and PQ are perpendicular. And then if they are perpendicular, you already know the gradient of PQ. Therefore, you can find the gradient of AM. The gradient of AM will be -1 divided by -2,75. And by so doing, you have 0,36. Let me answer this question. Okay, is there anyone else who has a question besides Carlos? No, it's okay. So you can see that AM here is AM, here is PQ. We can see that indeed AM and PQ are two perpendicular lines. Therefore, you already know the gradient of PQ, which was -2,75. To get AM, the gradient of AM, you just do -1 divided by -2,75. And you're going to get the gradient of AM, which is 0,36. All right, so we have determined already the equation of the radius AM. So the next question here is to determine the coordinates of M. Remember, we know already the coordinates of A. We know the equation line of AM. Now, we are asked to determine the coordinate of M. So what you'll do here, you just have to say that M is, you know, the coordinate here is X and Y. Therefore, you're going to see that, remember that you have found already the line of AM. We have found already the line of AM, which in this case, remember, it was 0.36 plus 4. Here we have used the fact that AM is a point on the line AM. Therefore, we use again the point 0, 4. Substituting it into y minus y1 equal to m bracket x minus x1 plus c, you're going to see that you're going to have your x1, which is 0. You're going to have your y1, which is 4. And when you bring the negative 4 into the right, that's where you see that you have positive 4. And that positive 4 is your C. So that's why we have y equal to 0.36x plus 4. Now, we are asked to find the coordinate of M. We are asked to find the coordinate of M here. Remember that the coordinate of M here will be xy. Now, the y here also is 0.36x plus 4. From this, you can clearly see it here. You're going to see that you have x, 0.36 plus 0.36x plus 4. Now, if we go back to the circle, you're going to see that AM, remember that the radius AM here is the same as, in fact, it's supposed to be AM squared. So you're going to see that the radius, because A, if we go back again to the circle, you're going to see that even C, they said that C was a point on the circle. So you're going to see that if you check here, you have A, which is a point on the circle. You have C, which is a point also on the circle. Now, what we do here, we do the distance between AM. Remember, the distance between AM squared will be equal to also the distance between MC squared. So you can say AM squared equal to MC squared, for example. In fact, you're going to see that AM is the radius. We can also say that MC is the radius here. Therefore, you know that the radius must be equal. That's why you see that we say AM squared equal to MC squared. Okay. So that's why we have AM squared. We have AM squared is equal to CM squared, or you can say AM squared equal to MC squared. So in fact, I think I made a mistake. It's supposed to be AM squared, which is equal to CM squared, because we have seen that the distance AM is the radius, and also CM or MC is the radius. Or those two radius must be equal to. That's why you start with right now. AM squared is going to be X minus 0 all squared plus, now the y, remember y of m is 0.36x plus 4 minus 4 all squared. So this is the distance, which is equal to now x minus 4 all squared plus 0.36x plus 4 minus 4 all squared. Now, when you do the calculation by expanding, you're going to have x squared plus 0.12 96x squared equal to x squared minus 8x plus 16 plus 0,1296x squared. So when you work this thing out by grouping the like term together and by factorizing, you're going to see that in fact x will be equal to 2. You'll have 8x, which is equal to 16. And then when you work it out, you have x equal to 2. I don't know, is there anyone who has a question on this? On this? Or all of us, we are okay on this question. So you were asked to find the coordinates of m. The thing that you're supposed to know is that a from A to M is the radius, and it's also the same as C to N, which is also the radius. Or you know that in a circle, the radius are equal. Now, the radius on its own is also a distance. Therefore, you can say now AM squared, which is equal to CM squared. You already know the coordinates of M, which are x and 0,36x plus 4. Now you know how to find the distance. So you do y2 minus y1 all squared plus x2 minus x1. This is the distance squared. So by so doing, you're going to see that the x coordinate of m is already 2. So you just come and substitute the x value in the y of m. You're going to have 0,36 times 2 plus 4. 0,36 times 2 is 0,72 plus 4. Therefore, you're going to see that the coordinates of m are 2. You have the x coordinate of n are 0,36 times 2 plus 4, which is 4,72. Therefore, you have the coordinates of m are 2 and 4,72. All right, let's quickly look at the last question. So the last question here was for us to find the equation, to write the equation of the line under the form of the radius, center. So center and radius form. Or you know already MC. You have the coordinates of M, you have the coordinates of C. So you do square root of 2 minus 4 all squared plus 4,72 minus 4 all squared. That will give you 2,13. Therefore, you see that MC squared here will be 4,52. MC squared is equal to 4,52. Therefore, you're going to see that the center radius form is going to be, remember, is center radius squared. Remember, the radius here is 2,13, but the radius squared, you just do 2,13 squared. So that's why you see that you have x plus 2 squared plus bracket y minus 4,72 all squared equal to 4,52, because m here was the center of the circle. M was the center of the circle. Therefore, you just take the point -2 and 4,72, and it will give you the center point. The only thing that you're supposed to just do here is to also calculate the radius. Or the radius, you just use the point MC, and it's going to be 4,52. Radius squared is 4,52. Okay, is there anyone who has a question? Is there anyone here with a question? So at the end here, what you can just take home as a message is to be able to use the gradient of the tangent line and to be able to apply it in a complex problems. You must be able to use the equation of the line, the tangent line, the equation of the circle and the tangent line for you to be able to apply it in complex problems. So you can have some of these useful links, and And if you have any question that you like to ask also individually, you can also email me to petsonp46@gmail.com. Thank you, and I'll see you tomorrow.